All right, so for this problem here, I want to talk about how capacitors combine in series and parallel, as well as how voltages divide across capacitor networks. So let's do this. I guess let's first find the total capacitance of this whole circuit here. Um, so as many of you know, when we combine resistors in parallel, there are two ways that we can do it. So we've got, if we only have two resistors in parallel, so here's resistor 1 and here's resistor 2, uh, then we've got two options. We can do what's called the product over sum, which is R1 times R2 over R1 plus R2, or if we've got uh, two or more resistors, we can use this method, which is 1 over R1 plus 1 over R2, and that continues on to the nth resistor. So you could do this with as many resistors as you please. You can see that this method here is going to get a little tedious after a while, but this is how resistors in parallel combine. Well, with capacitors, it's the exact opposite thing. So capacitors in series combine like this. So it's going to be C1 times C2 over C1 plus C2, or 1 over C1 plus 1 over C2 plus dot 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 1 over Cn, which means you can do it as many times as you'd like with as many capacitors in series as you'd like. So basically, when capacitors are in series, they combine in the same way as resistors in parallel, and vice versa. So when capacitors are in parallel like this, C1 and C2, then the resulting capacitance is simply C1 plus C2, which is exactly the opposite of how resistors in parallel combine. So let's apply this to this network here. So as you can see, we've got a 4.7 microfarad in parallel with a 0.47 microfarad. So those are just going to add together. Let me do that. So 4.7 micro is 10 to the minus 6. So 4.7 microfarads plus 0.47 microfarads. And that is 5.17 microfarads. So I'm just going to write that right here. 5.17 microfarads. So that's just these two. Okay, so we've got the same thing going on right here. See these two guys, 1 microfarads that are in parallel? Well, they're going to combine to be 2 microfarads. All right. Well, we've got 2 microfarads that's in series with 3.3 microfarads. So we're going to have to use this formula right here. So it's going to be 2 microfarads times 3.3 microfarads divided by 5.3 microfarads. So let me do that real quick. So we got 2 microfarads, times 3.3 microfarads divided by 5.3 microfarads. And so that is 1.24 microfarads. So this whole branch right here is 1.24 microfarads. So this whole branch here is in parallel with these two branches. So we can just add this branch, and this whole branch together. So it's going to be 5.17 microfarads plus 1.24 microfarads, and that is 6.41 microfarads. So C total is 6.41 microfarads. All right, so we've just found the total capacitance of this circuit. Well, now I want to know, what is the voltage across each cap? Well, over here, it's easy because this node here is 0 volts, this node is 12, so there's 12 volts across this one. There's 12 volts across this one. But here, we've got 12 volts across this whole network here. So we're going to have to do voltage division using caps. So I want to know, what is the voltage across C2 here? So here's how we do it. So it's going to be the total voltage being divided, that is 12 volts, times, and it's going to be the total capacitance of the divider. So that's going to be CT, but not this CT. It's going to be the total capacitance of this divider, which in this case is 1.24 over CX, where CX is the capacitor in question that we're looking for the voltage across. And so that's going to equal VCX. Okay, so let's do that. So 12 volts times 1.24 microfarads divided by, what's the capacitor I want the voltage across? I want the voltage across the 3.3 microfarad. Right there. And looks like microfarads is going to cancel out, which is handy. So it's going to be 12 volts times 1.24 divided by 3.3, and that's going to give us 4.5 volts. 4.5 volts. Okay, so we got 4.5 volts from here to here. Well, if there's a voltage drop of 4.5 volts right here, then the remainder of the 12 volts must be across these two. These are in parallel, so they must have the same voltage across each other. So the voltage across C3 and C4 is going to be 12 volts minus 4.5 volts, which is 7.5 volts. So from here to here, there's going to be 7.5 volts, like that. And there'll be 7.5 volts across this guy as well. So that is how voltage division works with capacitors, and this is how capacitors combine in series and parallel. All right, that's it for this one.